Hi, I'm John, Executive Director of the American Rose Society. So glad you're joining us today. We're so excited about these Consulting Rosarian programs, especially the one on fertilizer today. Today we will have Kim Merritt. She will be going over how the program is going to go through. Kim, if you could go over the program.
Thank you, John. Thank you all for attending today. I just want to go over the flow of today's seminar. So we'll start off with Ms. Linda Schupner that will introduce the speaker today, Mr. Chris Woods. After Chris's presentation, we will go into a 30-minute Q&A session. So that's kind of how the flow will go today. Now, if you are watching the seminar today with someone else, please post in the chat pod who you're watching with. That way we can note you properly on the attendance. Okay, so we're going to go ahead and get into the seminar. And Miss Linda, you're on.
All right. This is Linda Schupner. Hello out there in cyber world. This is a very exciting thing, not to be sitting in person in a Consulting Rosarian school. It seems like this is the new thing, and I'm really liking it. And I'm introducing our fertilizer person today, Chris Woods. He's a friend, but he is a very active Rosarian, and he was president of the Atlanta Rose Society a few times, and more times than probably he likes to count was Rose Chair for our big Rose show on Mother's Day weekend every year. And he's struggling with PowerPoint issues right now, but he knows a lot about roses. He knows a lot about fertilizer. And I have to share one little thing. When I said, Chris, tell me something I can say about you. And I'm going to share it because I thought it was very appropriate. He said, AKA, I'm AKA the master of manure, the conqueror of compost, and the king of KRAP. I won't say it loud on the broadcast, but anyway, he is going to talk to us today about fertilizer and poop in general. And Chris, I'm going to turn this over to you if you can keep that PowerPoint showing. Thank you all.
I'm going to try, but I've got my tech support person, aka
good.
my son, hiding off to the side. So if it goes away, maybe I can keep it going.
All right.
All right. Hopefully everybody can see the fertilizer presentation. And I want to start off by telling everybody, if you'll notice, this presentation's been around a while. 2012, the original was created up there in the Pacific Northwest District, and it's been revised several times and used quite a few times by many people. But the reason I wanted to bring it up is if you need a copy, it's out there on the ARS website under presentations. So you can actually find it yourself if you need to. It is eligible for CR credit, blah, 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 blah. And we want to thank all the people who've contributed over the years. But let's start off with a definition of fertilizer. Main thing I want everybody to know is fertilizer is not plant food. It's plant vitamin pills. Plants make their own food from the sun, but they need the vitamins, they need minerals, they need things to grow and live. Specifically, long ago, I was taught a little mnemonic, C. Hopkins Cafe, managed by my cousin Moselle, which if you spell it out is the chemical symbols of every element needed for a plant. Most of those are the major elements: carbon, hydrogen, oxygen, a couple of what I'll call medium elements, and then a whole bunch of micronutrients. Plants can get these from the soil. They're in everybody's soil most of the time. I mean, specifically, if you look at it, the breakdown, what is that, 99.8% are just the top 10, but those last 0.2% are still very important. to a growing plant. And I am not seeing the little chart. Ah, that's because it's here. Everybody, I hope, went through the soil presentation, I believe it was last week or 2 weeks ago, where they talked a great deal about pH. Every one of those nutrients is some sort of chemical compound which has a positive or negative charge, and pH, which is the amount of positive and negative charges in the soil anyway, is incredibly important to whether or not the plant can even use the fertilizer you give it. Roses specifically will tolerate, I really want to say tolerate. They aren't happy with a 5.5 pH. They aren't happy with a 7.8 pH. They can survive. But the reality is they really want to be somewhere between 6 and 6.5 on the pH scale. If you think you have some sort of nutrient deficiency, chances are almost always it has to do with the fact that your pH is too high or too low. I happen to live in Georgia red clay, where our normal pH of the dirt is about the same as orange juice.
Yeah.
We always have to raise it. Others live in places where the pH is naturally too high. They have to lower it. But if you want to grow good roses, you better be somewhere in that 6.0 to 6.5 range. Maybe you can stretch it a little, 6.7, 6.8. But they really, really like right around the 6.4, 6.5 zone. If you haven't adjusted and tested and adjusted your pH, most of the fertilizer you're going to have is just going to be useless. If you're lucky, it'll wash through. If you're not, it'll build up as a salt in your dirt. I'm just clicking through a little bit here of the stuff we just said. Oh, here's one that I forgot to mention. This scale is logarithmic, which means it takes just as much free negative ions to go from 5 to 6 as it takes to go from 6 to 6.1. This means that your early adjustments can be pretty quick, but getting it really locked in on the 6.5 zone takes a lot of time and a lot of effort, and it's worth it. Because something to remember is almost all fertilizers kind of make the soil more acidic. Those of you who have alkaline soils, take note of this. Fertilizing is good. Here's a chart we've seen quite a few times. It's throughout all sorts of botany literature, but it is a really critical thing for us to note. Each and every one of the elements has a kind of a happy zone where the plant can take those nutrients in, and a very unhappy zone. Get a too much acidity in your dirt, and your soil just won't, the plants won't use it. Get too much alkalinity, and a different set of nutrients just won't be absorbed by the plant. How to keep your pH correct? Well, we add lime, but by the way, it takes a long time to change the pH in your soil. It's really an every year thing to add some lime for me. If I forget, which I have before, first thing I know is all of my plants just aren't really happy. And it takes time to get them back happy because, again, takes time to move the pH around. Obviously, we do soil tests, right? Yeah. Even a home pH meter, you don't have to spend $100 or so on a Kelway. I recommend it, but just the cheap ones you can get at your local garden center are still useful for knowing, in general, are you too acidic or too alkaline? Use a soil test to get really accurate. One thing to be aware of is there is a mineral, magnesium, which you can easily overdo. It kind of like poisoning yourself with too much vitamin C. You just need to use a soil test. They'll tell you, do you need to add calcitic or dolomitic lime to raise your soil pH? If the soil is too alkaline, one of the things to do is add composts. That'll lower it a good bit. It is a slow and hard process. Fertilizers help too, because as we said before, they almost all make the soil a little more acidic. Some of them make it a lot more acidic. And as we'll see in a few minutes, there are a great number of sulfur-based fertilizers that lower it pretty quickly. However, I feel a great deal of pity for those who have alkaline soils. I can raise my soil acidity a lot easier than you can lower it. It's a challenge, we know. When you go to your local garden center, you're going to find bags of fertilizer. Lots and lots of bags of fertilizer by different brands and different wonderful marketing names. This is Rose Spectacular or whatever. Reality is, ignore that and start looking at the details. They will all list the three major components: nitrogen, phosphorus, and potassium as a ratio: 10, 20, 20, 20, 20, 20, 10, 10, 10. It goes on and on and on. This is a start. Nitrogen fuels the growth of the plant. Helps it get nice, big, strong canes. Dark green foliage. If your foliage is, yellowish, maybe it needs a little more nitrogen. But you can overdo it. Again, your soil test will tell you how much you need. One thing to be aware with nitrogen is it dissolves in water. So it kind of washes through the soil. Phosphorus, the middle number, helps root growth, helps the plant grow down. Big blooms, big roots, grow big stems, grow big blooms. Sounds like a winner. It really helps going into a winter like we're having now to have strong roots, mature plants, mature stems. Some of you way up north, you need more than just that. But here in Georgia, if I've gotten my plants winterized fairly well, they're mature, they're gonna last through what little snow and ice I'll get. But again, I have to make sure my pH is right, or it just doesn't get available. Phosphorus does not really dissolve in water. It doesn't move very quickly at all. So you kind of need to work it in. When you first plant the plant. There are a lot of high phosphorus fertilizers available at the garden center with names like Root Starter or New Plantings. Those are just fertilizers high in phosphorus to mix into the soil as you plant the plant, because it's not going to move very far. Superphosphate, one that everybody's familiar with because it's almost pure phosphorus. 45% phosphorus. The last of the big three, potassium. Just an all-around thing your plant needs. This is kind of like the plant equivalent of everybody eating a banana. It's something we as humans need too, but plants need a good bit of potassium. They can't really make their own food unless they have chlorophyll, and chlorophyll is something that potassium is a major component of. Moves nutrients through the plant. It's just a good thing, but oh, by the way, it also, again, is water soluble. You can wash it out after a reasonable amount of time. It'll move through the soil. And we start looking at the rest of the fertilizer bag label. We saw those first numbers, you know, the NPK, but it'll start giving us what makes up that nitrogen. And this is very, very important, because ammoniacal nitrogen and urea nitrogen really acidify the soil pretty quickly, far more so than one of the other alternatives we'll hit in a few moments. Water insoluble nitrogen is really stuff that's not even going to be available to your plant, because it needs to dissolve it in order to get there. There are some bacteria that break it down, and it therefore is kind of a slow release. All the other things, the magnesium, sulfur, it's kind of like when you buy a vitamin pill at the grocery store. Very few fertilizers give you just one vitamin. They all have a bunch of them. And just like our vitamin pills, you know, my Centrum Silver, it contains a lot of things that I may not really be lacking in. But as long as it's not giving me so much that I poison myself, I keep going. One of well, we'll get to it. Secondary macronutrients. This is the middle level. We need quite a few of these. Calcium, magnesium. You know, magnesium is a very essential part of the chlorophyll production as well. You've got to have it to have green, healthy plants. Sulfur. Sulfur is in almost all of our soils. As long as your pH is right, your plant will absorb it. But it does lower the pH, because sulfur is one of those ions that binds with a, well, I won't go into the chemistry too bad. Let's just say sulfur lowers pH. And then there's all the gazillion micronutrients. Very, very small amounts needed. Too much of them quite often causes a problem. Too little of them causes a problem. How do you tell which you need? Again, that famous soil test. Iron is one that a lot of us lack. Here in Georgia, you'd think with this red clay, by the way, the red is caused by iron, I would not have an iron deficiency, but it gets locked up in those tiny clay particles so much that I have to actually add iron. It's just an essential little ion. It's needed for several things in the plant. Manganese. Again, zinc. These things are just absolutely necessary, very small amounts, but if you don't have it, you'll have some difficulties. There's a lot of these micronutrients. Boron helps with the formation of starch. That starch, by the way, that's photosynthesis. It creates little bitty tiny carbohydrates that then get clumped into starch so the plant can store it and move it around. Copper, a bunch of these little micronutrients. Again, when you go to the garden center, pay attention to how much is in there and how much you need based on your soil test. It takes a while reading the bags to figure out which ones have what you need. And they're all labeled wonderful things. Just pay attention to the little fine print. That's what will count. But let's talk about how the fertilizer comes to you. Sometimes you get it in granules you can just scatter on the ground and maybe scratch it in with a rake. Sometimes it's designed to be dissolved. I've got a big trash can I fill with water and then pour in some various things to dissolve them and then carry them out and water them on the plants. Liquid. Here's one that, quite often we can just mix that with our spray and spray it on the leaves. Or, again, mix it in my big trash can and pour it out around the base of the plant. And last but not least, those wonderful spikes that you can buy that say that they, release the fertilizer across 3 to 6 months. They do it because they dissolve very slowly. By the way, if you think about it, a liquid, almost instantly it's flowing down past those roots. It's available. Powdered, pretty close to the same, just may take a little more effort to get into the bucket and the water bucket to pour on it. Granular takes a little longer. The rain has to dissolve it. Your watering system has to dissolve the fertilizer and get it through the roots. The solids take the longest. Did I get to that one? Yeah, okay, there we go. Fertilizers, broadly divided into sourced originally from other living things, plants, or chemical, sourced originally in a lab. As far as the plant is concerned, there's not a whole lot of difference, but the organic seems to, let's just say, be more acceptable to our soil. The chemicals can easily be too much too quickly. The organics really don't seem, when you read the bag, that they are all that high in nutrient content. I mean, it'll be like a 3-5-3 or something like that on the bag, as opposed to 30-20-10. But don't pass them up, because they have those trace elements just naturally in them. They're far better to be able to do if you've got the time. Chemicals work very quickly, though. Organics tend to need springtime. They need the soil to be warming up to do any good. High levels of carbon, that's one that hasn't been mentioned before, but plants use carbon to build themselves, stems, leaves, flowers, everything. And it slowly adds just to the general soil health. Chemicals come in all forms, but they're mostly composed of synthetically created components. To that end, they don't have a lot of side benefit, other things. In general, they're all various forms of salts that, depending on your soil pH, get converted into the form that the plant can use. They need water available to the roots, and they all build up as salts in the dirt. If you use the chemical, the inorganics, every few years you probably need to use something that will, like Clearex, to just flush all of the salts that have built up in your soil. it'll just interfere with everything over time. It's a good idea to use something like that. Again, I mentioned the product Clearex, because it does get rid of the salts that just kind of get clogging everything up. However, everything that comes in the chemical form is pretty quick. It's already been engineered to go straight to the roots. And plants really can't tell the difference. The only, the chemical is the chemical is the chemical, whether it was produced by Mother Nature or produced by ortho. Some of the common organic, you'll recognize these, the various meals, cottonseed, blood, bone meal. They all have their high benefit components, as well as a bunch of side benefit components. Alfalfa meal, this is one of my favorites. I always make a big pot of alfalfa tea every year. I just take a couple of scoops of literally rabbit food alfalfa, pour it in the bottom of the 30-gallon trash can, fill it with water, put the top on, and let it stew. Word of warning, when you take that lid off, the stench is unimaginable. The stuff really smells. So only do it just before a rain, or your neighbors might get very angry at you. Compost. We all know the benefits of compost. Stirring in just improves the soil immeasurably, but has not just the micronutrients and fertilizer components, but also contains beneficial fungi. It's just good stuff. Fish emulsion. You remember my comment about the alfalfa tea? Same thing kind of goes with fish emulsion. It can smell pretty strongly. It also can be pretty intense for the plants. So use it kind of sparingly. I personally prefer to mix a little bit in when I'm spraying my fungicide, just to give it a little foliar spray. Mushroom compost. It's just decomposed mushrooms. It's very similar to decomposed cow manure, horse manure, etc., except for it's a little bit lower in its ratio because it doesn't go through an animal, it goes through a fungus, and it's just good compost. Seaweed, kelp extract, same comment as the fish emulsion. It can smell. Manure, composted manure, not fresh manure, okay? Fresh manure has potentially quite a few harmful things in it. Fresh cow manure or horse manure may contain a lot of weed seeds. You need to make sure it's been thoroughly composted. Also beware, some manures, especially bird manures like chicken manure, can be extremely high in nitrogen and burn the roots, or burn, same thing that we said earlier. Too much nitrogen can burn the plant. Last and certainly not least, things like millorganite, which is just composted sewage, but very good, very, very useful compost. There's no telling what really may be in it because it's come from the sewage treatment plants of major cities, but it is a decent compost. One thing that people talk about is slow release versus fast release. I'm repeating myself a little, the organics all tend to be fairly slow release. Some of the chemicals tend to be incredibly fast release. Some of the chemicals they've carefully designed to not be incredibly fast release. Osmocote is one that springs to mind. It's designed, it's wrapped up in a substrate such that it dissolves slowly over time, and like those plant spikes, can deliver fertilizer over a course of months. Many of these are designed but to be, well, like the organics, digested by bacteria and fungus in the soil to make it available to the plant roots. Many of these slow release fertilizers are engineered to have various triggers. It's amazing what they can do when they really get into designing, and I do mean designing a fertilizer. It's not haphazard. This is serious engineering. And it has an advantage, which is you can get the benefits of those engineered nutrients without being at risk of getting fertilizer burn from too much too quickly. You do need to be aware of something. I don't have to worry nearly as much as some others here on this call, but there comes a point in the fall where I do not want any new growth. It's just going to get killed by the winter frosts and is going to weaken the plant. I want to let the plant go to sleep. So I won't put in a slow release fertilizer really after July, because I don't want it to get to October or November still releasing fertilizer. I'll switch to something. I still want my plant to get fertilized, but I'll switch to something that goes through pretty quickly. Spray on the seaweed extract as a foliar spray or something in, I could do that even in September, and it's gone, and its effect is gone before the frosts hit for me. So do be aware when you're putting out your fertilizer. How long is this going to last, causing growth in my plant? Too much water, plants release too fast if it's a water-soluble fertilizer. Too little water and the plants don't get any nutrient release. It just kind of sits there unavailable. So much for all those warnings. Nitrogen, as we said early on, is one of the biggies. It's probably the number one fertilizer component for roses, making them grow. And it comes in several forms. First one I want to talk about is nitrate nitrogen, which is really simply, it's just nitrogen with 3 oxygens, some salt of nitrogen with 3 oxygen atoms attached. This is how plants absorb nitrogen in this format. Therefore, nitrate nitrogen is the fastest acting, most available to a plant. There's one called ammoniacal, which is ammonia, NH4, combined with the NO3 molecule. This is one that makes the soil very acidic. All of those hydrogen atoms get released as positive ions in the soil. Positive, negative. Ooh, losing my mind. Ammoniacal nitrogen is more pH lowering than nitrate nitrogen. It does, however, have an advantage, which is it has to get changed in the soil to nitrate nitrogen by bacteria in order for the plant to use it. So it takes a little longer to be available, not much. Urea is even a step beyond ammoniacal in that it has to go change to ammoniacal and then to nitrate in the soil in order for it to be accepted by the plants. So the urea is the slowest of availability. but it also, because it goes through that ammoniacal step, lowers the acidity, lowers the pH, makes it much more acidic than just pure nitrate-based nitrogens. There is one other form of nitrogen, nitrite nitrogen. Many of you probably know it because you see it as a food preservative quite often. But as a fertilizer, it really has some drawbacks. The number one of which is it's quite expensive as compared to nitrate nitrogen. The primary difference between nitrate and nitrite is just one oxygen atom, NH3 versus, or NO3 versus NO2. It's not worth the money to try and get it. Just go with the nitrate nitrogens. Or again, if you have naturally alkaline soil, the ammoniacal or urea based to lower your pH. Here we go with some things that we see a lot. Nitrogen deficiencies. The plants are yellowish. Things just aren't growing well. It's just too low. The plant's alive, it's just not happy. Another thing that's very similar is an oxygen deficiency. But it usually happens because there's just too much water. The soil is too soggy and there's no oxygen in it, or it's too compacted. You can add nitrogen, it doesn't do any good, then probability is you've got an oxygen deficiency. There is when you look carefully at the leaves, the veins will show a yellowing as opposed to just the interveinal yellowing. Some other imbalances that we see a good bit: iron, exact opposite. The area between the veins show yellowing while the veins themselves are green. There are pictures of this in the CR manual, by the way. Makes it easier to pull it out and take that page with you if you're giving somebody some assistance or even analyzing your own yard, to go out there and say, what is it? Leaf burn, over fertilization, too hot, spray burn, which is kind of similar to the over fertilization. The poor plants just got chemical burn there at the edge. As we said originally, 99% of the time, nutrient deficiencies are a problem of pH. It can't take what's there. And this is saying the organizer has stopped my webcam. John, is this a problem? No. Can anybody hear me?
We can hear you, Chris. What we can't do is we can't see you, but I think you're fine.
Okay. All right. Well, hopefully you're looking at the presentation anyway, not my beautiful face.
Yeah, we are.
Okay. Anyway, the nutrients are present, but they're unavailable because of the pH range. Pretty much every time I've had a problem with nutrient availability, it's been because of my pH, and I just hadn't noticed. Okay, why is this thing not? There we go. Yeah, it's just saying the same thing I just said. Generally, micronutrients are there. They're in your soil. It's just naturally there because you don't need very much. In fact, you need so little. But the pH can make it so you don't see it at all. Again, in the CR manual, the pictures are worth thousands of words because some deficiencies do affect older leaves first. For instance, nitrogen deficiency, magnesium, phosphorus, potassium. Some deficiencies affect younger plant parts first. And if you'll notice, it's the micronutrients that are in the younger plant section mostly. The biggies are in the older leaf version to be affected first. But where you see it, old leaves versus new leaves, helps you diagnose, do I really have a micronutrient problem, or I'm just kind of short on fertilizer in general, need to add some NPK. Oh, by the way, magnesium is easily gotten in many forms. Some people even add Epsom salts to try and encourage basal breaks, Epsom salts being magnesium. Just use your CR manual, the pictures in there, well worth it. And you can always just kind of think about, what have I done? Have I added fertilizer with micronutrients? Have I done anything to help my pH lately? That'll always help you figure out what nutrient deficiency you really have. And as usual, the nutrient deficiency is pH problem. There are some do's and don'ts. Do test your soil. Do wait until the soil is kind of warm. There's no need for any of us to go through fertilizer right now on top of the snow. The constant use of chemical fertilizers is going to build up salt. You're going to have problems. You can add organic material. One thing I love doing is throwing some food out for the worms, so they will, come eat the coffee grounds from around my plants, and in the process both aerate the soil and leave behind little worm castings. Overfeeding. Don't overfeed. You really don't need to fertilize very often. Here's one of the last that's very important. If you're throwing fertilizer out on a dry plant, it's not doing any good. It probably is doing harm. Water, especially water before you throw out fertilizer to get the ground ready. Water after you fertilizer to dissolve it in, get it down where the roots are. Fertilizer on the surface doesn't do much good. You need to get it where the roots are. Here we have an incredibly high-tech applicator and spreader. What that is a tin can on the end of a pole, just scooping and shaking some fertilizer around the base of the roses, and kind of raking to get it worked into the top surface of the soil. And then after that, water it. Hopefully you've watered it beforehand as well, as we just said. One thing that's always a good memory aid is up, down, and all around. Nitrogen, up. Phosphorus, roots. Potassium, just all around health. Good little mnemonic. Oh, it's got. And now the section comes as questions, which I have no idea even if or how we ask questions